second law of motion. Now, all of us know that we call the definition of acceleration. That is the change in velocity during the time interval. This is the acceleration, v, delta v over t. Now, what is the cause of that? Who makes the acceleration? Who makes the object to accelerate? All of us know if I have this book here, this book, it will be at rest until there's an applied force act on it. So the things or the reason to make this book moving is what? Is a force. So the cause of acceleration is a force. So let's start now with the first lesson, 6.1, force causes acceleration. Unbalanced forces acting on an object cause the object to accelerate. Look at this hockey puck here, as you see in this picture down here. This hockey puck is at rest. Why it's at rest? Because there's no force act on it, or there's not the net force. What are the net force acting on this object here? Or me, I'm sitting now on the chair. Okay, I'm here. I'm sitting now on the chair. I am at rest. Why am I at rest? Because the net forces that acting on me is zero. Sorry, there's a normal force or support force acting on me upward, and there's a gravity force acting on me downward. So that's make me at rest. But if there's one come and push me, there's an acting force acts on me now. This force, let's make them now unbalanced. This unbalanced force, it makes me to move, or it makes me to accelerate. So if there's a net force equals zero, if the net force is balanced, there's the puck or the object it will be an equilibrium, so it will be at rest. It doesn't move. If you hit the puck, you hit it now, you apply a force on it, so it makes a change on the motion. It's accelerate. So if you act an object with a force, you push or you change the position of this object, so it's accelerate. If you apply extra force, you will also change the motion or change the acceleration again. So unbalanced force, balanced force, the net force is zero, the object is at rest. Unbalanced force, you accelerate the object. So the object now start moving. Now, as you remembered, as we see in our previous quiz, we say that the F of net or the resultant force is zero. Why? Because the balanced force that's acting on it from the right and from the left are equal. Inshallah, in this chapter, we will say that the net force, because the object is moving, is not zero. You have unbalanced force. You will say that's the product of the mass times the acceleration. This one, that's mean the object here is accelerate. The first one, there's the forces, or we have a constant acceleration. There's an balanced forces acting on them that make the net force zero. So the F of net here, later on we will see that how the force is equal to the acceleration times the product of M. Let's see now. Let's start now with the first one, which is force causes acceleration. Now, recall from the previous chapter that the combination of forces acting on the net, on the object, is the net force. Acceleration depends on the net force. As I told you, if there's no force, if the force is zero, there's no acceleration, because F is m times a. If there's no force, yeah, the acceleration will be 0. So the acceleration depends on the net force. To increase the acceleration, you have to increase the force. Like you are driving your car. You want to accelerate your car. You have to extra push, or you have to extra make a force on your car. So if you want to accelerate, or if you want to increase the acceleration, you have to increase the force. That's why the acceleration depends on the net force. So the acceleration is directly proportional to the net force acting on it. This simple. It's mean outstand is directly proportional to. So the acceleration is directly proportional to the force. Is it clear?
Yes.
How is the acceleration? Depends on the force. Increase the acceleration, you will, or increase the force, you will increase the acceleration. Now,
Teacher, M is the mass.
yes.
Okay.
This is early talk about them. Now let's talk about mass resist acceleration. So the force proportional, or has a directly proportional with the acceleration. Now, but there's something, it resists the acceleration, which is the mass. How is the mass resist the acceleration? Imagine now you are in the hypermarket and you have a shopping cart. Which is easier for you, to push an empty shopping cart or a heavy loaded shopping cart?
The first one, the one with the empty.
The empty, yes. So
And
now you are the same person. If you push the empty one, or if you push the heavy loaded one, you act with the same magnitude of force. Here, I'm pushing 5 Newton on both them. But the first one, since it is empty, so it accelerates more, it goes quickly than the second one. The second one, since it's heavy, so its acceleration will be less than the empty one. So I am the same person. I'm push the empty one, so I walk quickly. But if I'm doing it at the same force, but I'm pushing the heavy one, I will walk slowly than the first one. That's why the mass resists the acceleration. When I push something that's heavier than, my velocity or my acceleration will be less than the heavy one. If I want now, yes, Rose.
And teacher, it depends on how strong you push it. Like also it depends on the person, like how strong it pushes. Right? Like
How?
maybe the 5 Newton, the one that pushed it, like 5 Newton with the this empty cylinder card, it's more strong. Of course, it will be more stronger than the one that it is heavy. But if the heavy push it more strong than the empty one, it will be more quickly. Like it depends on the one that it's pushing, right? The force, how strong the force is.
What? Sorry.
Like it depends on how strong the force is. Not only if it's heavy or empty, right?
Wait. Yes. Here now we say that if I'm acting with these two cards with the same force, with the same magnitude of force. Now, if you want now to make them move at the same acceleration, here is 2 and here is 2, And the first one, it has only 1 kilogram. And the second one, it has 3 kilograms. So if you want now them to move with the same acceleration, the force will be different. The first one, you need only 2 kilograms. So your strength will be less than if you move one with 3 kilograms, because here you need 6 Newton, and here you need only 2 Newton. So if you want them to move at the same time, at the same acceleration, you need to act 3 times the force of the second one. It will be 3 times the acting force on the empty one. So push on an empty cart, then push equally hard, the same force, 5 Newton, on a heavily loaded shopping cart. You will see that the loaded cart will accelerate much less than the empty cart, as we said before. So what does it mean? That means the acceleration depends on the mass. So the force depends on the acceleration, and the acceleration depends on the mass. So the same force applied to twice as much mass result in only half the acceleration. Like if you want to act or to apply same force in both of the objects, if the first one has a mass of the second, like twice the mass of the second one, that means it will accelerate half the second one. Like how I told you, you have 5 Newton on both of them. Here you have, or let's say I have another examples, like 2 Newton here and 2 Newton here. For the first one, if its mass is 2 kilogram, the second one is 1 kilogram. Here it will accelerate 2 meters per second square, and here it will accelerate 1 meter per second square. So both of them, you apply on them the same force. But in the first one, since its mass is twice than the second one, it's 2, so its accelerate will be half than the second one. Here, this mass is twice the second one, and here this acceleration is half than the second one. Is it clear?
Yeah.
So you applying with the same force. That's if you apply on a big object, your acceleration will be less than if you apply with an light on. Your mass, yeah, your mass here, if you apply with the same force, your mass in the second object will be twice, if your mass of the second object is twice than the first one, so your acceleration, it will be half than the first one. That's why 2 times 1 or 1 times 2 is equal to 2. So what does it mean? That means the acceleration is inversely proportional to the mass. The acceleration is inversely proportional to the mass. Inversely, that means what? That means they are acting or adding on opposite direction, not like directly. That's we talk about them in chapter 8 in algebra. Inversely and directly. Directly, it is like y equal k over x, and y equal k. This is inversely, sorry, and this is directly. Y equal kx. This is directly. Okay, so in here the mass acceleration,
Yeah,
inversely proportional
in the chemistry
with the mass. So inversely means that the two values change in opposite direction. as the denominator increase, the numerator will be decreased. So the acceleration produced depends on the mass that is pushed. So the acceleration depends on the mass. The force depends also on the acceleration. Now let's derive.
But teacher,
Yes.
you mean like when we increase the acceleration, like the mass of the object will decrease?
Sorry, can you repeat?
Like when we increase the acceleration, the
Yes.
object of this, like the mass of this object will decrease?
If you increase the mass, the acceleration will decrease.
Okay.
Okay. So by now we say that the force is, or the acceleration, sorry, is directly proportional with the force, and the acceleration is inversely proportional with the mass. Let's combine them. You will say now the acceleration is the force over the mass. The acceleration is proportional directly with the force and inversely proportional with the mass. If you arrange them, you will see that the force acting on them is M times A, which is the Newton's second law. And that's what we will talk about them tomorrow, inshallah. Do you have any question?
No, thank you.
No, thank you, teacher.
No, thank you, teacher.
No.